Hi guys, you're welcome to my channel. All right, today we're going to discuss about PLC logic programming. In our previous exercise, we discussed about reversible motor starter. Take a look at this portion. This is a sample of schematic diagram for reversible motor starter. This is the power circuit. Then today we are going to talk about how to write a simple program for logic control. Okay, now this portion now is my ladder schematic diagram. This is my ladder logic. This is my ladder logic, right? Okay. Now, if you want to write a program for PLC, we convert. I told you the previous time that the schematic that we are using, if you want to convert it to ladder diagram and they burn it and they download it to PLC, that is going to be on vertical run like this. Remember the other time we did horizontal, rather we're going to be horizontal shape instead of vertical run. So here is the ladder diagram. Okay, you don't have enough space here. I would have displayed the control circuit for this particular schematic so that you see the hardwired diagram. You now see the ladder diagram. You now see the difference between the two diagrams. Okay, now let's discuss about the operation sequence of this particular device called PLC, Programmable Logic Controller. This is my power circuit, and this is my ladder diagram representing the operational sequence of this. So the behavior of this is going to be dependent on the arrangement of this ladder diagram. So we use this one to illustrate how this operation will go, right, and the process of this operation. Okay, now this is my PLC. This particular PLC is called Siemens Logo PLC. This is Siemens. We use this particular PLC for small scale industrial setup, for small scale programming logic. So if we need, we also have another one, we also have a 1200 series. Let me see if I can display that 1200 series. We have it here. 1200 series. Okay, in another edition, I can do that. I will display that later. Let's just finish this. All right. Okay, now this is my Siemens Logo PLC. Now, like I said before, when writing this program, one, you must learn two things simultaneously when writing a program. You must learn how to write the program and also learn how to carry out the connection process. Connect your simulation and your logic programming into PLC. So here now, here, let me analyze this. Here, these are my input devices, and these are my output devices. These are my output, and these are my input bit. The whole of this input logic, and this is output logic. Okay, now, this is my overload. Let me represent it here. This is my overload block, and this is my overload input switch. Then this is my stop button, and this is my start button. This particular portion will take care of one of the contactor for the motor to run on clockwise direction. Then this other portion will take care of this other contactor to close for the motor to be subjected to backward operation. Then the connection of these input devices, my switches, and my start and stop input devices, these are the process. This one is the overload, being this. This one is stop button, that is this one. Then this one is my start button for forward operation, that is this, S1. This is my start button for backward operation, and that is this one, S2. Then my overload for the system to shut down in terms of fault, that is this overload block. This is a contact, this is auxiliary contact that will trip. Then this 1, 2, 3, 4 being my output devices, here you can find them here. This forward operation, backward operation, these are the coils, that are the contactors, right? Then these are indicator lamp to indicate when any of this is active. All right, let's see if we can simulate quickly. Okay, now let's simulate. I use this other one because when you have something like this, you must have what we call HMI, human interface, right, machine. Now we have, for instance, I have this motor situated in the field. And this PLC possibly may also be in a panel inside a control room. So I will have something, a kind of a sub-starting position, because this one is not accessible. This one may be right with the panel that was enclosing this portion. So these switches may be discovered where this one is going to be situated. Why this one will be a kind of providing an interface starting position. That is our HMI. It can generate HMI interface so that you can now start and stop from your control room. Okay, by the time we go into programming proper, you know the difference between this one and HMI. So you can start from here. You can also start from here. So let's now see if we can illustrate. Let me start from here first. I start the logic here. Okay, first of all, I put on my power. My power is on now. Take a look at this display unit. This is my input bit. These are my output bit. So if I put on any of the system, the bit will indicate here as well. Then this contactor will get energized and this lamp will come up, right? And this other contactor, whichever forward operation or backward operation that is initiated, will also come up. Then take a look at this motor. You see arrow pointing the direction of the rotation that the motor is being subjected to, right? And this is my breaker to protect surge from coming to my PLC. All right, I put it on. Now this one is closed and this motor is subjected to forward operation direction now. This one is closed. If I shut down from here again and start the second one, this one will also come up. So direction will change, right? And this one will come up to illustrate as well. Now, peradventure there is a fault coming from the mechanical impeller or mechanical mechanism of the machine. So this my overload will react. This one will respond to the fault by tripping the system. So let's see if we can create a fault. So we can create fault here. All right. The system now shut down and I have alarm. This is my alarm lamp coming up, indicating, telling the operator that there is sorry, there is a situation, there is a fault in the system. So having gotten that, you now go into your system and carry out what we call fault finding or troubleshooting process. Having rectified the fault, all you need to do is to come and reset the system, reset the motor, and the system will now go back to normal. It can now restart any of the operation the second time. All right. Okay. Thank you. Then the next exercise, I will now pass you through, walk you through how you can write this program. All right. Thank you.